Yeah, let me repeat, sir. Well, now let us take number of objects are n and the total capacity of the knapsack is w. So we need to have a table of size what O of n into w. But for considering the number of objects equal to 0 or weight equal to 0, for considering the base condition, we are taking the table size of what? O of n plus 1 into w plus 1. Okay, this will be your table size. We are taking same example here, same as what we discussed earlier. This is your weight, this is your profit, and the weight of the first object is 1 and the profit is 10. The weight of the second object is 2 and the profit is 12. The weight of the third object is 4 and the profit is 18. This is your object 1, object 2, object 3. Well, now the capacity of the knapsack is 6. The capacity of the knapsack is 6. So we need to have what? 3 objects and capacity is 6. We need to have a table of size 3 by 6, but for base condition we are converting this into what? 4 by 7, right? Yeah. Now I'll be drawing the table here. See here. Let me draw it for you first. Yeah, I'm just drawing it. 0, 1, 2, 3, 4, 5, and 6. This is talking about what? Capacity. Yeah, this is talking about what? Objects. First object, second object, third object, and this is 0. Well, now we will see the story. Listen, if the capacity is 0, whether you have 0 objects or 1 object or 2 objects or 3 objects, the maximum profit will be 0. When you have 0 objects, even though capacity of the knapsack is 1, 2, 3, 4, 5, 6, the profit is 0. Yeah, that is a base condition. What I'm trying to tell you, this column is telling what the capacity is 0. Irrespective of number of objects, the profit will be 0. Now, what this row is telling, number of objects are 0. If number of objects are 0, whatsoever be the capacity, that is 0. That is what we know. And I'll keep my expression in handy so that we'll be knowing the things, right? Yeah. What are the conditions we are having here? Max of profit I plus knapsack of I minus 1 comma wi, sorry, w minus wi comma knapsack of I minus 1 w. This is first one, 0. When this one wi is greater than w. Next, here it is what? Either k is equal to 0 or w is equal to 0. I is equal to 0 or w equal to 0. Next, what? Ks of I minus 1 comma w, where wi, this is less than, this is greater than w, right? When the weight is less than the capacity of the knapsack. Yeah. With this, we are able to understand each and every problem carefully, right? Now, either you can go row major order or column major order. I am going for row major order. What I am trying to do, first I will be considering knapsack of 1 comma 1. What is the meaning of this one? We are considering we are having only one object and the capacity is 1 and the capacity is 1, right? So I value is 1, W is 1. Now what? Either I can include the first object or I may ignore the first object, right? But before trying to include that object, you need to know what is the current capacity and what is the size of the object. The current capacity of the knapsack is 1. The current capacity of the knapsack is 1 and the weight of the first object is also 1. What does it mean to me? I can include. Means what? Which case I need to consider? This case. What this case is telling, what this case is telling, you can take max of 10. As you included this object, the object size should be reduced by 1, means one object is reduced. And how much weight you included? One weight you included, so 0. This is the first possibility you have. And the second possibility is what? Don't include that object and the capacity of the knapsack is 1. That's what we are telling, right? Yeah, we know knapsack of 00 is what? 0. This is 0. And knapsack of 01, 01 is what? 0. So 10 plus 0 is 10, comma 0. Maximum of 10 comma 0 is what? 10. Means what? The current capacity of the knapsack is 1. If you include that object, I will get the profit as 10. If you don't include that object, I will get the profit as 0. In this maximum is what? 10. That is the reason 10 is coming here. Now what I need to do? Row major order I was telling, right? Case of 1 comma 2. What does it mean to me? I am considering only first object. I am considering only first object, but the knapsack capacity is 2. Knapsack capacity is 2. What I need to do? Maximum of, yeah. Why am I going for maximum? Because this case is satisfied. What is the meaning? One object is there, that weight is less than the knapsack, right? 10 plus, as this object is already considered, we need to reduce the number of objects. And how much weight I need to reduce? Only one weight was introduced, right? That is the reason weight 1. Comma, don't include. If you don't include, we need to remove that object and knapsack capacity is 0. What is the meaning? When the knapsack capacity is 2 and you have only one object with you, only you have one object with you, this will give you 10, this will give you 0, right? 0 1 is 0 1 is 0 and 0 2 is also 0. Maximum of this will be what? 10. Next, knapsack of 1 comma 3. Yeah, what is the meaning of this one? We are considering first object and the capacity is 3. Same thing we need to do. Maximum of 10 plus ks of what? Number of objects are reduced by 1. And how much capacity you added? Only one capacity. So 3 minus 1 we need to do. It's not straight away minus 1. We are reducing the capacity, right? WA value is what here? 1. And the capacity was 3. 3 minus 1 we need to take 2. And here it will be same case of 0 comma 3. 0 comma 3. Yeah, 0 2 is 10. Sorry, 0 2 is 0. 0 3 is 10. We'll get 10. Same way you can go for what? Case of 2 comma 4. This also will be 10. If you want, you can see case of 2 comma 5. This will also will be 10. If you want, you can compute it. Case of 2 comma 6. This will also be 10. Yeah, up to here we are very clear. Now what I need to do, ks of 2 comma 1. What is the meaning of this one? We are having two objects. And the capacity is 1. We are having two objects and the capacity is what? 1. Now try to see. Now I need to take the second object. Why? Because I am taking second object and one first object also. I will take both objects. Please understand, again I am repeating. 2 means it is not about second object. It is about two objects. It is about what? Two objects. Now I will take second object. What is the capacity? What is the size of that object? 2. But the capacity of the knapsack is what? 1. Means what? The current object capacity is 2 and currently the capacity of the knapsack is 1. Then what should I do? I need to ignore that object, remove that object, and the weight is same. Why weight is same? Because I did not add any object, right? Case of 2 comma 1 will give you what? Case of 1 comma 1. What is 1 comma 1? 10. Again I'm repeating, understand. What is the meaning of this line? We are having two objects. It is not the second object. We are having two objects, but the capacity of the knapsack is 1. Means what? You are having first object, second object, and the weight of the first object is 1, weight of the second object is 2, the profit is 10, the profit is 12. If the capacity of the knapsack is 1, the maximum profit will be this one only. If you want, you can check it out. Yes. Now, very, very important, this is listen. Case of 2 comma 2. What is the meaning? We are having two objects and the capacity of the knapsack is 2. Well, is it possible to include the second object? We need to see. Is it possible to include the second object? Yes, because the size is 2. What can I do? What is the profit associated with that? Max of max of 12. 12 is a profit, and we need to remove one object. Okay, we removed. And as I included the second object, capacity of 2 is taken. 2 minus 2 will be what? 0, comma, ks of 1, comma 2. What is the meaning of ks of 1, comma 2? One object is reduced, but weight is still. Now, ks of 1, comma 2. 1, 2 is what? 10. 1, 0 is what? 0. 12 plus 0 is 12. 10. Max of 12, comma 10 is 12. What is the meaning of this one? Can you please tell me? When you are standing here, when you are standing here, the capacity of the knapsack is 2 and we are having two objects. Now you tell, when you have two objects, which object if you can include, you will get the maximum profit only second object, right? Why? Because the capacity of the knapsack is this one. Next, let us take ks of, this is very important, 2 comma 3. What is the meaning of this one? We are having two objects and the capacity of the knapsack is 3, right? Yeah. Now, first we'll go to this object. What is the capacity? 2. Can I include this object? Yes. When you include this object, always consider this case. Max of, when you include that object, I got the profit as 12 and I need to reduce the number of objects and the size is reduced to 1. Why 1? Because 2 is already included. Comma. If I don't include that, we'll be getting what? 1 and 3. Yeah. Now we need to see 1 1. What is 1 1? 1 1 is 10. 1 3. 1 3 is what? 10 plus 12. Now tell, see, if you were not having the table, if you were not having the table, 1 3, if you were not having the table, 1 3 should have been computed. If you want, you can see here. Whatever I'm trying to tell you, please listen. Yeah. Here I computed 1 3. Might be this is the first 1 3. For 2 3 also you wanted to compute 1 3, but I am not computing it here. Why am I not computing it here? Because already this value I stored in the table. Already this value, right? When I was talking about 2 3 only, I'm telling, right? Yeah. So when I computed this 2 3, this one I computed. Whenever you wanted to compute this 2 3, I'll not take this one. That's what the meaning of taking the value from the table, right? Yeah, might be some people may ask, sir, why are you not going to case of 1 3? Because already I populated that value in the table. Already I populated that value in what? Table. Just 1 minute. Let me get well. 12 plus 10, 22. This is 10. The answer we are going to get is what? 22. What is the meaning? See, now listen, you will understand. Now, totally we are having two objects and capacity is 3. So it makes more sense to include the both objects. Why? Because this capacity is 2 plus 1, 3 and the weight is 22. Next, what I'm trying to do, case of 2 comma 4. What is the meaning? Total number of objects 2, capacity is 4. So max of 12 plus ks of 1 comma 2 comma ks of 1 comma 4. Yes. What is 1 2? 1 2 is what? 10. 12 plus 10, 22 and it is 10. The maximum is 22. What is the meaning? The capacity of the knapsack is 4, but total weight itself is 3, right? You can straight away include. Similarly, if you can do ks of 2 comma 5, total weight itself is right. This will also be 22. Similarly, if you do ks of 2 comma 6, this weight also will be what? 22. If you want, you can check it up. Yeah. So just I need some space. So what will I do? I'll just take this and keep it down so that I can use the space for my next solution. Now, ks of 3 comma 1. What is the meaning? Now we have three objects. Three objects are there with me, but the capacity of the knapsack is what? Capacity of the knapsack is only 1. Is it possible to include this object? No. If you are not able to include this object, then what is the meaning we need to consider? Remove that object and consider as 1. 2 1. 2 1. What is 2 1? 10. Is my point clear? Yes. So third object I cannot include. Next, ks of 3 comma 2. Third object size is what? 4. We cannot include. So remove that object and take the 2 2. 2 2 value is how much? 12. Total value is 12. Next, Ks of 3 comma 4. Yeah, this is very important. Now, what is the meaning? We have three objects. We have three objects, and the capacity of the knapsack is 4, right? Capacity of the knapsack is 4. Now, is it possible to include? Yes. Then what can I do? Maximum of the profit is how much? I need to take 18. Huh? Yeah. Let us take 28. Till now, I did not discuss that. Either 18 or 28, whatever the value you take, can take. Yeah, because we assumed 28 initially, right? What I'm trying to tell, I assumed initially 28, right? Yeah. Till now, I did not discuss that person, so don't worry, right? Yeah, 28 plus which object I included? Third object. When you included third object, number of objects are reduced to 2. Number of objects are reduced to 2, and the total weight is taken. Right? 4 minus 4, 0, right? Yeah, comma. Don't include that object. Don't include that object. And the capacity is 4. No, 2, 4. What is 2, 4? 22. What is 2, 0? 2, 2, 0. 2, 0 is what? 0. 28, 22, which is maximum? 28 is maximum. Well, next case of 3 comma 5. Yeah, what is the meaning? Totally we need to consider three objects. Totally we need to consider three objects, and the capacity of the knapsack is 5. Capacity of the knapsack is 5, right? First object, second object, third object, 1, 2, 4, 10, 12, 28. 10, 12, 28. I think I'm clear so far. Yeah. Now, what is the meaning? Max of, I can include that object, so I'll get the profit plus case of, remove that object and reduce it to 1 by 5 minus 1 is 4, comma, remove that object but don't reduce the size. Yeah. What is 2, 5? 2, 5 is 22. What is 2, 1? 2, 2, 1 is 10. Now you'll understand what I am trying to tell you, right? What is the total capacity of the knapsack? 5. And you have three objects. It is more clearly telling I can include this object and I can include this object. 28 plus 10 will give you 38. Yeah, it is more intuition wise also clear, right? Next case of 3 comma, 3 comma 4 is how much? 28 only, right? Yeah. Case of 3 2, case of 3 2 is 2 2, 2 2. Case of 3 2 is 2 2. 1 minute. 3 2 value 12. Okay. 3 3 I missed it. Okay, let us take case of 3 3 also first. Yeah, case of 3 3 will be what? Case of 2 2 only, right? Yeah, case of 2 2 only, right? It will be also 2 2 12. 1 minute. Case of 3 3 will be what? 2. Let me write it first here. Case of 3 comma 3. Yeah, case of 3 comma 3 will write. Yeah, case of 3 comma 3 is what? We cannot consider this object. We cannot consider this object. Why we cannot consider 4, right? So what can I take here? 2 3. 2 3. 2 3 value is what? 22. So 3 3 value also will be 22. I think this is what? 22. Okay, fine. Next case of 3 5 will be what? Case of 3 5 will be 38. Next case of 3 comma 6. Case of 3 comma 6. What is the meaning? We are having three objects and the capacity is 6. That's what our target, right? So max of 28 plus ks of 2 comma, we need to go to 2 comma ks of 2 comma 6. Yeah, what is 2 2? What is 2 2? 12. What is 2 6? What is 2 6? 2 6 is 22. And this is 28. 28 plus 12 is 40. Yeah. So this is your maximum. This is your maximum profit. Yeah. See, case of 3 3 is not 2 2, right? Why? I already told you here, case of 3, 3 is 2, 3. Okay. What is 2, 3? 2, 3 value is 22. So this 20. I think I missed 3, 3. And anyways, I discussed. Now what we need to do? We need to write the code for this. But before we write the code for this, I'll give you some small snippets to understand. Once you understand the small snippets, I'll straight away write the code. I hope I'm clear so far. Yeah. Now we need to write the code, right? So for writing the code, what I'm trying to do, I'll take one array. The array name, what I'm going to put here is profits. Profits array is equal to same profits I'm taking 10, 12, 28. And I'm taking another array that is weights. Weights is equal to 1, 2, 4. What does it mean to me? First object profit is 10 and weight is 1. Profit is 12, weight is 2. Profit is 28, weight is 4. And I'm taking another one int capacity. What is the capacity I took? 6. Well, now we will visualize this in the form of an array now. This is 0, 1, 2. I'm talking about profit array. 10, 12, 28. 1, 2, 4. 0, 1, 2. This is what your weights. And we know the capacity is 6, right? Now let us take, we have a knapsack like this. Let me draw below this so that it will be easy for me. What are the cases we are talking? I'll just show you, right? 0, 1, 2, 3, 4, 5, 6. Perfect. 0, 1, 2, 3. Now let's consider the scenario is like this. Ks of 3, 6. What does it mean to me? You are considering third object. Third object, correct? Third object is present in which place? Weights of I value is 3, right? Ks of I comma w. That's what I'm trying to tell you, right? So what is the meaning? I minus 1. What is the value of I? 3, w 6. Remember, I value is here 3, w value is here 6. We know that anyway. Now weights of I minus 1. What is weights of I minus 1? 4 is less than or equal to capacity. Is this condition true or false? We need to know. What is the weights? I minus 1. I minus 1 is what? 2. Weights of 2 is 4, less than or equal to 6. True. True. True means what is the formula we need to write? Ks of 3, 6. That is nothing but in the programming, how should we write? Ks of 3, 6 is equal to max of what should I take? Profit of the third object. Profit of the third object, right? Yeah, I took profit of the third object. Third object index is represented using 2. Profits of I minus 1, right? What is this one I'm taking? Profits of I minus 1. What is profits of I minus 1? 28. Plus, what should I do? Whenever you are having third object, if an object is completed, we need to take from the remaining objects, right? Yeah. Plus Ks of 2, 2, comma. What is the meaning of 2? Take from the remaining 2 objects. Next, what should I do? I need to reduce 6 by 4. I need to reduce 6 by 4. This 4 is present where? In the weights of 2, right? In the weights of 2. How do I get that one? Weights of I minus 1. What is weights of I minus 1? Weights of I minus 1 is 4. That value should be removed from your W. That value should be removed from your W. So what should I write here? Knapsack of I minus 1. I minus 1. I value is 2. 2 minus 1 is 3. And here you wrote what? 2. 6 minus 4 is 2. How did you get this 2? W minus weights of I minus 1. Yeah, let me repeat this again so that you will get the clarity. Don't worry, I'll repeat this again. What I am trying to tell you, Ks of 3 comma 6 means what? Consider the third object and total capacity is 6. What did you get here? If you can tell me, max of 28 plus Ks of 2 comma 2. What is the meaning? One object is reduced, and 6 minus 4 is 2. 6 minus 4 is 2, comma Ks of 2 comma 6. Ks of 2 comma 6. This is what we wanted to write. So here I value is 3, W value is 6. I value is 3, W value is 6. Now, how did you get 28? Where is the 28% in the second location of the profit, right? So Ks of IW is equal to max of profit of I minus 1. What is I minus 1? 28 plus Ks of these two. How did you get I minus 1? You remember the expression? Next what we need to get, these two. What is this two? 6 minus current object weight, right? 6 minus current object weight. 6 is what? The current capacity minus current object weight. How do I reduce? That is present in weights of I minus 1. That is present in weights of I minus 1. Now if you can see, I minus 1 value is 2. Weights of I minus 1 is 4. 6 minus 4 is 2. That is what I got. Comma. Next what should I do? Knapsack of. I need to reduce this. And the weights remaining same. In these two, whichever the value is maximum, we need to take, right? I minus 1 means what? 2, 6, right? 2, 6. Here you have some value, and here you have some value, and some value you got here as 28. 28 plus this value is bigger, this value is bigger. Whichever the value is bigger, store it here. That is what we got as 42. 40. I think it was 22 here, and it was something around 22, some value 12. I think 12 plus 20 I got as 40. That is what I'm interested to tell for you people, right? So when this logic will work, when the current object weight is less than the capacity. Assume another case. Let me take this case. Just 1 minute. Assume another case. The case is, I'm taking about this case. Let us take Ks of 3 comma 1. Ks of 3 comma 1. What is the meaning? The value of I is 3. The value of W is 1. What is the meaning? The current capacity is 1, and totally we are considering 3 objects, right? So weights of I minus 1. What is the meaning of weights of I minus 1? I value is 3 means this is your current weight less than or equal to capacity. Right? What is my capacity now? I considered one is my capacity I consider, right? Is my point clear for everyone? The current capacity I considered is 1. Condition is false. If the condition is false, what should I do? We need to go for what? You reduce this and let it be here. Correct? So Ks of IW will be what? Ks of I minus 1 and W. This is when the current object weight is less than the capacity. When the current object weight is less than the capacity. I think it should be Pretty clear? If you have any doubts, you can just go through it once. You can just go through it once. Yeah. So please everyone understand, whatever the capacity here I'm telling is, this is not the capacity of the knapsack. I am telling the current capacity. Anyway, current capacity is indicated with what? W. Instead of capacity, you can just replace it what? W, right? W is always the current capacity. See, here capacity is just I am using the term. The term capacity is referring to what? Here current capacity. Current capacity is this one. This is present in the one. So code wise, what should you write here? One. Code wise, you should write what here? One. W. Anyway, I will write the code for you next so that you will understand. Yeah. Now we will write the code. What I'll write, I'll write int knapsack. See, this is the not only the standard way, you can write in any way. Int we have capacity, comma, int we have weights, array, weights is weight array, int we have what? Profits array, and we have number of jobs, right? Number of objects, number of objects. Yeah, you can write NOPJ, simply number of objects. Number of objects. Now, what is the first step I need to do? Int I comma W. I is current location of the object and the W is the current capacity, right? Yeah. Next, what should I do? Int. Let me take knapsack of knapsack of knapsack of number of objects. Next, number of objects plus 1. Next, capacity plus 1. So now we have created a array of size. Number of object was 3, 3 plus 1, 4. Capacity was 6, 6 plus 1, 7. We have created an array of 4 by 7 size. We have created an array of 4 by 7 size. If you want, you can create it here. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3. This is what your case array. 0, 1, 2, 3, right? Yeah. Now we know this is your profit array. We have 10, 12, 28. And this is your weight array. 1, 2, 4. This is talking about your profit. This is talking about your weight. That is what passed here. Next, what should I do? I need to start from 0 to 6 and I need to go from 0 to 3, right? So for I is equal to 0, I less than or equal to number of, same variable name you use, object, number of object, next I plus plus. So the value of I will be what? 0. I value will be what? 0, 1, 2, 3, and when it is 4, false. When it is 4, false. So when I value is 0, I need to start from where? W is equal to 0. W less than or equal to capacity. W is equal to W plus 1. Now what is the value of capacity? Capacity value is 6. So W value will start from 0, 1, 2, 3, 4, 5, 6, 7 is false. 7 is false. Okay. Now, what is the meaning? Whether I is 0 or I is 0 or W is 0, populate that value to 0. How do you write that? If I is equal to 0 or W equal to 0, what should I do? Ks of I, W equal to 0. Whenever you write this line, this all values will be populated, not now only, when that line is executed for every iteration. Now, what should I do? Else if weights weights of I minus 1 less than or equal to current capacity. See, current capacity is represented using W. No doubt this code will be executed when W is 1. If W is 0, this code was executed. Then what should I do? Ks of IW is equal to Ks of W is equal to maximum of profits of I minus 1, profits of I minus 1 plus Ks of I minus 1 W minus weights of I minus 1 comma comma Ks of I minus 1 W. Yeah. Else, when will I go to else? If this condition is false, this condition is false, right? Else Ks of IW will be what? We need to remove the object, but the weight will still remain the same. Yeah. Once this is completed, the value of I will reach 4 and the value of F will reach 7, but the answer will be present in 3, 6. That is the reason what should I do? Return Ks of I minus 1 W minus 1. Well, let's take the same case, whatever I discussed to you people. I was talking about Ks of 3, comma 6. 3, comma 6. What is the value of I? 3, W 6. Means I am talking about this case. Previously, we know, if you can see, this value is 22, this value is 38, and some value you can take. Some these values are there. We'll see that values anyway. We'll see that values anyways here. Now, definitely this condition is not satisfied. Now we are at this condition. What is the meaning of weights of I minus 1? Weights of 2. What is weights of 2? 4 less than or equal to current capacity is 6. 4 less than or equal to 6 is what? True. Means this code is executed, this code is not executed. Now I'm talking about this code. Max of what it is telling? Profits of 2. Because I value is 2. Profits of 2. Profits of 2 is how much? 28. Plus what I need to do? Ks of 2. What is the current weight? 6 minus. Now I need to reduce 4. This 4 is present in what? Weights of 2, right? That is the reason weights of 2. Weights of 2 is already how much? Weights of 2 is already, 4. 6 minus 4 is how much? 2. Means Ks of 2, 2. Means I need to consider 2, 2, this value. Might be it will be 12. If I'm not wrong, it will be 12. Yeah, it is 12. This 12 plus 28 I'm adding, right? Yeah, this is what I'm doing. 2, 2. This value I'm adding. This value will be 40 and this value will be 22. We need to see that one also. We'll see that. Now we know that this value we got is how much? 12. Right? Yes. So 28 plus 12 is 40. And it is asking Ks of 4, sorry, 2 and 5. 2, 5 value was 22, right? We know that because it was populated throughout the course of this 22. So the value of this one will become what? 40. This code is not executed and I value will become 4 and W value will become 7. 4 less than or equal to 7 is false anyway. Sorry, 4 less than or equal to 3. 4 less than or equal to 3 is false. You will come and you will return. This is one case what I was talking about. The another case what I was talking about was this one. Yeah, the another case what I was talking is, let us take you are at the case of 3, 1, right? Case of 3, 1. Let me erase this first. Yeah, I'm talking about what? Case of 3, 1, right? Means what? I'm talking about this case. Okay, now you'll understand what is the meaning. I value is 3, W value is 1. 3 less than or equal to 3 was true. 3 less than or equal to 3 was true. W was 0, 1. Now, definitely this case is not satisfied. Now I'm standing at this case. I'm standing at this case. Well, now weights of I minus 1. weights of 2. Why? Because I value is 3. 4 and the current capacity is what? 1. 4 less than or equal to 1 is false. That is the reason I came to this case. What it is telling, ks of 3 comma 1 is nothing but ks of 2 comma 1, right? So for this, what value you will get? Whatever the value is present in 2 1, this value only we need to take. Why? Because this is the maximum capacity I have, right? When means only one capacity I have. Whichever the object is giving to you that capacity, whichever the profit is giving with one capacity, you are taking that one, right? Now see, at any point of time, if you can see, if you are standing here, what is the meaning? In these two objects with the capacity 4, how much maximum profit you will get, right? When you are standing here with these three objects with capacity 5, how much profit, right? At any given index, let us take you are standing here. What is the meaning? In these three objects, when the capacity was 3, what is the maximum profit? It will be here. When you are standing here, what is the meaning? In these two objects together, what is the maximum capacity? Sorry, maximum profit when the capacity was 4. That is what the actual meaning, right? Now, you know, right? The loop repeated up to number of objects. So this one will be what, O of n plus 1, and this one will be what, O of w plus 1. So the time complexity will be what? O of n into w. And the space complexity, we took what here? This is the time complexity, and the space complexity what? N into w. Now listen. Please listen. Well, the time complexity is O of n into w when we approached using what? Dynamic programming. When we did using what? Dynamic programming. When we did it in brute force, naive method, the time complexity was what? 2 power n. This we know. But so many people are thinking this is linear and this is exponential. But the fact is, the result of this time complexity in the case of dynamic programming, the result of this time complexity in the case of dynamic programming is dependent on W. If W is assumed 2 power n, means the capacity is very big, then the time complexity of this one will be what? O of n into 2 power n, which is worse than your naive approach, which is worse than your brute force, right? If W is, let us take n factorial, it is worse, right? O of n into n factorial, it is still worse because we know 2 power n is far less than n factorial. We already know this long back, right? So the time complexity of this program is dependent on what? The capacity of the knapsack. So till now the proof is it could be either minimum of O of n into w or O of 2 power n. Might be this type of multiple choice questions are also coming. We need to be very clear, right? So if smaller means definitely it is less than 2 power n, then we need to use dynamic programming. If not, we need to use our naive approach. So with this, we have completed 0 1 knapsack, but I will try to execute this on the machine and I will try to show it to you people.